Hello everyone, my name is Abhishek and welcome back to my channel. I'm sure many of you must have used Apache Kafka, but only some of you might have realized cost implications and challenges with Apache Kafka when operating it at scale. There are two primary reasons. Number one, brokers of Apache Kafka writes data to the local disk. These days everyone go for SSDs. Some of you might be using high performance SSDs as well. Imagine amount of data brokers write to the local disk. And local disks are cost inefficient solutions by the cloud providers. Second, cross-zone networking costs. For replicating data or for backing up the data, each broker replicates its data onto the other brokers. In a high available setup, each broker is in a different availability zone. So when one broker replicates the data onto the local disk of other broker, this leads to cross-zone networking costs. Cloud providers like AWS, GCP heavily charge you for this. Don't worry, I will not only talk about problems, but I'll also talk about KIP-1150, which is a Kafka improvement proposal that is led by engineers at IOPS. The main goal of this proposal is to address all of these challenges by introducing Diskless Kafka feature. I'll talk more about this proposal. I will talk how this proposal addresses these challenges, and I'll also show you the current status of this proposal. Especially as an open source contributor, I'm super excited about this feature because the enterprise Kafka providers already started supporting this feature. So getting this proposal and feature merged into open source Apache Kafka project is going to help a lot of Apache Kafka users. So I should thank IOPS for leading this effort and also sponsoring today's video. Let's get started.
So let's start with the first challenge. Apache Kafka stores information to the local disk. Let's say you have set up a high available Kafka cluster on cloud provider like AWS. Something like this, where you have a 3 server or 3 broker Apache Kafka cluster. Every time when producer writes data to a topic, the partition leader, let's say this broker, stores data onto its local disk. In the world of AWS, we are talking about EBS most probably. Similarly, if this broker has to store the data, it stores information onto its local disk, which is a EBS volume. Similarly, this broker. Now, the major challenge here is that EBS is not a cost-effective solution. Not only AWS, if you're talking about local disk, any cloud provider, whether it is AWS, Azure, or GCP, storing huge amount of data to the local disk or to the local volume is a cost ineffective solution from the cloud providers. To add to it, when you are dealing with a HA or a high available Kafka cluster, to ensure safety of the data or to ensure proper replication of data is maintained, every broker, along with storing the information onto its local disk, they store copies of data onto the other brokers. Typically, at least 2 copies of data is maintained. Because for some reason, if this broker goes down, or maybe there is a high latency with this broker, for any reason, if there is issue with this broker, you still have 2 other brokers and they have data that is used for data streaming. Basically, the Kafka solution is not impacted. So that means the broker, if the producer writes 100 GB of data, let's say, so broker stores 100 GB of data to its local disk. Along with that, it stores another 100 GB of data, which is a copy to the local disk of other broker. Similarly, 100 GB of data to the local disk of the final broker. Overall, you will not be charged for 100 GB of EBS volume, which itself is an expensive thing, but you will actually be charged for 3 times of the actual storage. So this is a cost ineffective approach. However, this is the traditional architecture or the existing architecture where brokers store information to the local disk. Now to add to it, second challenge is actually an extension of the first one. That is cross-zone networking costs. So if you continue with the same example, so you have a 3-broker Kafka cluster, and this is a high available cluster. That means each broker is set up in a different availability zone. If you have your Kafka cluster in US East 1 region on AWS, then you usually set up one of the broker in availability zone 1A, other in 1B, and final one in 1C. This is actually a good architecture because if one of your availability zone goes down, which is typically a data center, or maybe if one of your availability zone faces high latency, you still have 2 other availability zones which are intact. But the problem with this approach when it comes to Apache Kafka, when this broker tries to replicate the data onto the other broker, similarly to the other broker, along with 3 times storage cost, which we just learned in the previous scenario, you will also be costed for cross-zone networking costs. Unfortunately, a lot of people are not aware that on many of the cloud providers, when you have an instance or when you have an application that is writing data to a volume which is in a different availability zone, along with storage, you will also be costed for cross-zone networking costs. This is on cloud providers like AWS, GCP, and many other cloud providers. So overall, from both the previous scenario and this one, when you're dealing with Apache Kafka cluster in the existing architecture on cloud providers, you will be charged for 3 times storage cost and also cross-zone networking costs. If you put cost aside for some time, there is also another challenge with the existing architecture, that is rebalancing of the Kafka cluster. So let's say you have 3-broker Kafka cluster and you want to scale up the cluster, maybe add a new compute or a new broker because you want more computing power to your Kafka cluster. You actually don't need more storage, but you are looking for more computing power. Unfortunately, because in the existing architecture, Kafka broker is tightly coupled with storage. That means if you want to scale up or add a new broker, you have to add local disk to the broker as well. Because every time this broker writes data, it writes data to the local disk. Maybe you don't need additional storage for your Kafka cluster, but still you don't have an option because broker by default writes information to its local disk. In the same way, if you want to maybe scale down the cluster, maybe you want to remove a broker, you have to ensure that data on the broker is rebalanced. Maybe you shift the data to the 2 other existing brokers. Maybe you have 3 brokers and you want to get rid of one. So you have to ensure proper rebalancing is done. And if you want to do it live without bringing down the cluster, it's an additional challenge. Because it's a data streaming solution, you cannot risk with the data. You cannot risk with the huge networking load that comes with rebalancing of the cluster. This might impact your customers or clients who are using your data streaming solution. So these are 3 major challenges with the existing architecture. Once again, storage costs, cross-zone networking costs, and rebalancing of the Kafka cluster. All of these things can be solved with KIP-1150. So KIP-1150 is a Kafka improvement proposal that is led by engineers at IOPS. So they have come up with a proposal to use diskless Kafka. At a high level, or the crux of this solution is to move from local disk to object storage on the cloud provider. What does that mean? So instead of broker writing data to its local disk, now it writes data to an object store like S3 bucket, GCS, or Azure Blob. So there is a clear separation between the broker and storage. Unlike the previous architecture, they both are not tightly coupled, so you don't have rebalancing issue. Now let's understand how this architecture solves all the three challenges. First one we talked about was storage costs. Because data is written into object stores like S3, and S3 or equivalent solutions are most cost-effective solutions. In fact, S3 is a very cheap solution on AWS. So if you compare EBS with S3, writing data on EBS to writing data on S3, it is multiple times cost effective. Not only that, when you write data to S3, you don't have to worry about backups. You don't have to worry about data durability because it is automatically taken care by the cloud provider. In this case, AWS. So when you write data to S3, AWS ensures your data is 99.119 durable. So chances of losing data or chances of your data being not available is very, very rare. So both it's a cheap solution and it is backing up the data in multiple availability zones, multiple regions. So your data is also highly reliable. So when you compare with 3x storage cost, if you are using local disk, this comes to only 1x storage cost. And also this is 3x EBS cost, whereas this is 1x S3 cost. So you can understand how many times this is going to be a cheaper solution. Now, if we talk about cross-zone networking costs, because that is another thing that we discussed. So when you're talking about cross-zone networking costs, S3 again, or GCS, or maybe Azure Blob, what these cloud providers do, they ensure data written to S3, GCS, or Azure Blob is replicated to different availability zones and different regions. So this way, you don't have to bother about the cross-zone networking costs, because when broker writes data to S3 or GCS or Azure Blob, it does not incur cross-zone networking costs. And you don't have to bother about rebalancing of cluster because storage and broker are not tightly coupled in this architecture. If you just want to add a new broker, you can add a new broker without worrying about the storage. Or maybe if you want to remove the computing power of a broker, you can just eliminate a broker. These two brokers still write the information to the object store. So this way, KIP-1150 by introducing object store solves all three major challenges with Apache Kafka. I mean the existing design of Apache Kafka. Now, if you want to understand more about this design, if you want to understand the technical side, how this architecture works internally, I have some very useful resources for you. So all these resources are hosted on the IOPS platform. They are written by the engineers at IOPS. So I'll share reference links to all the three blogs. One is Diskless Kafka, 80% linear, 100% open. I'll also share you reference link for this other blog where you have complete information of how KIP-1150 implements the Diskless Topics. And also you have this final thing which talks about cross-zone networking costs, DIS and TCO. One important thing to talk about KIP-1150. This does not, when this feature is merged into Apache Kafka, it does not eliminate the existing architecture. So this can be used along with the existing architecture. Maybe if you want to have one of your broker writing information to the local disk and you want to have other brokers writing information to the object store, that's still possible. You just have to run a command or you just have to switch a flag so that your broker can actually write data to the object store. So this design is completely backward compatible. Now, if you want to understand about the status, like Abhishek, when will this be merged to Apache Kafka open source project? You can track all that information through this Confluence page. I would highly recommend you to go through this page if you are interested in Apache Kafka and understanding KIP-1150, because this talks about background, it talks about cross-zone networking costs, it talks about motivation, and it also talks about implementation, which lines of code will be updated, which functions might be impacted, everything through this Confluence page. There is also Jira associated with this ticket or associated with this KIP. Kafka 19161. You can find that link in the description as well. Through this Jira, you can see who is assigned with this implementation and what is the status of the implementation. So this is about KIP 1150 and how this can address the existing challenges with Apache Kafka. Personally, I'm super interested about this because the enterprise Kafka providers or commercial Kafka offerings like Buffstream or maybe Red Panda, or even if you look at Confluent, so they started already supporting this feature. If this proposal gets merged into Apache Kafka open source project, and if IOPS delivers this feature to Kafka, this is going to be a great help to the open source community. And this will keep Apache Kafka as a market leader in the data streaming space. So that's it for today's video. I hope you found it useful. If you have any questions, do let me know in the comment section. See you all in the next one. Take care. Bye-bye.